on next function, that is smallest integer function, also called as ceiling function, also called as step function. What this, and the symbol for this will be this, it is closed from the ceiling part. So ceiling function is here. Greatest integer function or smallest integer, greatest integer function, I told you that was the floor function. So that function will also be written this way. This was the greatest integer function. In the previous lecture, I told this was the symbol, but in some books they are giving symbol this way also. Now we are concerned about smallest integer function. Now what this smallest integer function says, this function says that whatever the real number you are going to take, in that whatever smallest integer greater than this number will be coming in smallest integer. For example, I say it is f of minus 1.5. Minus 1.5. Where is minus 1.5? Here. Now in this case we are not going to consider the smallest integers. Now we find out how many integers are bigger than this. How many integers are bigger than this? Minus 1 is bigger, 0 is bigger, 1 is bigger, 2 is bigger. And among these bigger ones, which is the smallest? Whatever the point given to you, find out how many integers are bigger than that. And among them, whatever the smallest will be my answer. So here in this case, integers will be minus 1, 0, 1, 2, so on. So which is the smallest here? Minus 1. So your answer come out to be minus 1. Same way when I say f of 0.5. 0.5 will be somewhere here. How many integers are bigger than this? 1, 2, 3, and which is the smallest among them? 1. So this time what you are finding, whatever the point given in the question, its first right integer will be my answer. In the previous one it was first left integer, but this time it is first right integer. So f of 0.5, another example we can take f of 1.5. If you take 1.5 will be somewhere here. Which is the integer bigger than this? 2, 3, 4, 5, so on. So what my answer should be? It's 2. So we will say the integer which is bigger than this. Find out those, and among them whatever the smallest one will be taken as answer. So this will be the smallest integer function we have. And now we are plotting the graph of it. Now when you plot the graph of it, just check what will be the shape of this graph. This is your number line. 0, 1, 2, minus 1, minus 2. Here it is the numbers 0, 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2, minus 3. When you think about 0, 0 when you take, it's 0 only the answer? Yes. When you go for 0.1, that is somewhere here. When you take 0.1, what is my answer? That is 1. 0.1 if I take, then the integers bigger than this will be 1, 2, 3, and the answer will come out to be 1. So as soon as you reaches 0.1, your value gone to 1. Then 0.2, again the value is 1. 0.3 the value is 1, 0.4 the value is 1, 0.5 the value is 1, at 1 the value is 1. So this will go this way. At 0 it was 0, but at 1, so put the circle this side. At 0 the value is 0. As soon as you have gone this side, the value has jumped to 1. In the previous one, the circle was coming this side, but this time the circle is coming that side. Now at 1 it's 1. As soon as you reach to 1.1, what the value come out to be? So I'll start 0 here, circle, and as 1.1 your answer will be 2, so it will continue. At 2 the value remain 2. As soon as you go 2.1 your value jump to 3. This way. Same way when you go for it, what you will find? At -1 your answer is -1. Here it is. When you go for -0.9 your answer gone to 0. Right? So this will continue. And at -1 the value is at -1. Then we go for -2, its value is -2. When you take -2, it's -2, but when you go for -1.9, -1.8, your answer come out to be this. As soon as you reach to -2, it has gone down. Again, what you are finding here, this is in the form of steps. So that's why it is called step function. Ceiling function, why I told? Because you are going from the towards the higher side. So that is the ceiling function. Then, is it discontinuous function? Yes, it is discontinuous function. Where it is discontinuous? At all integral. 1, 2, 3, -1, -2, -3, it is broken. So discontinuous at integers. Recording. So discontinuous at integers. So in this case, this will be greatest integer function, discontinuous at integers. And if it is discontinuous at integer, we are not concerned about differentiability. Differentiability never going to discuss in this case. Can you find out what is the domain of this function? All the real number. Codomain of function, all the real number. What about range of the function? Will be only the integers. Just like the previous one, only the shape of the graph has changed. This is called ceiling function. Previous one was the this is ceiling, and that was floor function. Now coming on next one, Signum function. Next function is Signum function. It is Signum function. Function Signum, whenever you take this, defined this way: modulus x by x when x not 0. At x 0 your answer is 0. This is called our Signum function. Now in Signum function we should, as the modulus is here, we should redefine x not 0 means x is less than 0 or it will be greater than 0. When you go for less than 0, it will come as minus x, and this is x, so it come out to be -1. And when x is greater than 0, it will be x by x come out to be 1. And at x 0, it will be 0. So we have -1, 1 and 0. Whenever x less than 0, your answer come out to be -1. Greater than 0, it will always come out to be 1. And x 0, it come out to be 0. So now when you plot the graph for it, 0, 1, 2, 3, -1, -2, -3, 1, 2, 3, -1, -2, -3. At 0, your value is 0, so it is here. But whenever less than 0, your answer is -1. Less than 0 means all these values, your answer is -1. So that means the line will come like this. -2, it's -1, -3, it's -1, -1, it's -1, -5, it's -1. So this will continue with -1. But as soon as you reach to 0, your value has shifted to 0. Same way, whenever it is greater than 0, your value remain 1. And at 0, it has gone to 0. So here we will say in this part, this is the curve we have y is equal to 1. Here we have y is equal to minus 1. Only the problem comes at 0. At 0 it is broken. So we will say what type of function it is discontinuous. It is discontinuous at x is equal to 0. This function is discontinuous at x is equal to 0. Any other point, it is continuous. X0, it is continuous, discontinuous. And if it is discontinuous, differentiability not going to check. So keep in mind, this will be the curve we have of Signum function. Signum function has two parallel lines. One is y is equal to 1, y is equal to minus 1. These are parallel lines and only at 0 it is going to break. So this will be called as Signum function. You should keep in mind. What is the domain of this function? Domain will be all the real number because not 0 it is defined, 0 it is defined. Then we go for codomain, it is all the real number. But when you think about range of the function, we have only three answers. What the answer will be? Either the answer is minus 1 or 1 or 0. So the range will be this time minus 1, 0 and 1. This will be a set form. We will say this will be the range of the function. So range of the function is known. This will be called as a Signum function for us. So Signum function fx is modulus x by x where x should not be 0, 0 when x is equal to 0. So this will be called as Signum function. In this video I told you what is the smallest integer function. This previous video I told you greatest integer function, modulus function. These are standard functions and you should now have idea about its continuity and differentiability. These are the functions we will be taking directly. If someone says greatest integer function, we are directly going to say it is not continuous. We will say not differentiable. Same way Signum function, if someone asks, it's not continuous, not differentiable. If I say modulus function, I told you it is continuous everywhere but not differentiable everywhere. At a corner point, one corner point will come where it is not differentiable. So these are the functions we have done. Modulus function we have done, then identity function everywhere continuous and differentiable, then constant function everywhere continuous and differentiable. So these are the functions. In next videos we'll take more functions here. So these are the standard function because in calculus these are the standard function we are going to use frequently. So these functions you should have idea about this. These functions you should have idea. Thank you.